You think changing the past is impossible, don't you? What's done is done. The past is fixed, unchangeable. What if I told you that two physicists have written a paper proving they actually succeeded in changing the past? No, this isn't science fiction. This is quantum physics, and this is much weirder. You think you understand how time works right now. Past to present to future. Linear, simple, logical. By the end of this video, you'll understand that time, causality, and reality are not exactly what you think they are. And to be honest, physicists don't really know what they are either. Quantum physics works incredibly well. It predicts experiments with absurd precision, accurate predictions to 12 decimal places. But conceptually, it's a complete disaster. In quantum physics, we describe everything with something called a wave function, usually denoted by the Greek letter psi. From this wave function, we can calculate probabilities for measurement outcomes. But what is the wave function? Is it a real thing? Does it physically exist? What happens when you measure it? Physicists have been debating this for over 100 years. In physics, that still counts as early days. At the center of this debate is a very strange question. What exactly is a measurement? A physicist named Eugene Wigner set up this scenario to clarify this problem. Let's say a scientist produces particles so they exist in two places simultaneously, left and right. Then he measures and finds the particle on the left. But this person has a friend waiting outside the laboratory who hasn't seen the measurement result. For this friend, the entire laboratory exists in two states simultaneously, measurement result left and measurement result right, until he opens the door and looks at the result. This sounds absurd, and it really is absurd. But this is what quantum physics seemed to be saying. Normal people would leave it at this point, but physicists aren't normal. Instead, they derived theorems about this absurdity. Two physicists named Frauschiger and Renner expanded this setup. Two scientists, two friends, two laboratories. And the particles the scientists are working on are entangled in quantum entanglement. In this setup, there are situations where there's no combination of measurement results that everyone agrees on. This means two things. 1. Measurement results aren't objectively real. 2. Or all measurement results are objectively real, but each in its own universe. If the many worlds theory sounds familiar, this is where it comes from. But this wasn't weird enough yet. The new paper adds a twist to this idea. The two experiments aren't done simultaneously, but one after another. The first observer measures the quantum system and gets a result. Then the second observer comes and has two options. 1. Check the first result. 2. Cancel the first measurement and do a new one. If they check, they find the same thing. But if they cancel the first measurement and do a new one, the second measurement has possible outcomes that are incompatible with any definite result of the first measurement. As if the first measurement wasn't real, they erased the past. Wait a minute, you might say. What exactly does it mean to cancel the first measurement? It means that the interactions that made the measurement happen, say a particle hitting an atom and emitting a few photons, can in principle be undone. This should be possible because in quantum physics, every process can be reversed in time. Indeed, there are such experiments. Sometimes they make headlines saying, "Physicists reversed time." In reality, they're performing operations that undo exactly what happened before. The conclusion: in quantum physics, You can't treat past events as things that definitely happened or didn't happen. A particle's history might both have happened and not happened. Either this or every history happened in a different universe. This argument is formally correct and really mind-bending, but I draw a completely different conclusion from this. Not that the past doesn't have definite events. If you can reverse a measurement, then it wasn't a measurement to begin with. To me, this paper shows that we still don't understand what a measurement really is. I give this paper 2 out of 10 points. Nice paper, but with interpretation flaws. But I agree on the general point. Reconciling quantum physics with our everyday notion of causality is difficult. Very strange things are happening at the intersection of quantum physics and time that we haven't figured out yet. The real question is, what exactly is a measurement? The effect of measurement is converting the possibilities that the wave function describes into concrete outcomes. Before measurement, a particle can do strange things like being in two places at once. After measurement, it must have decided on one place. But exactly when does measurement occur? When the particle hits the detector? When the signal reaches your brain? When you become conscious of the result? This is known as the measurement problem and is one of quantum physics' deepest mysteries. Many worlds, consciousness collapse, hidden variables, all attempts to solve this problem. After 100 years, there's still no consensus. This paper is just one example of how time behaves strangely in the quantum world. There are delayed choice experiments. Your future decision seems to affect a particle's past behavior. Quantum eraser experiments. You can erase information that seemed previously determined and change the particle's behavior. John Wheeler's famous delayed choice thought experiment. Your present decision might determine how quasar light traveled billions of light years away. Time is not what we think it is, at least not in the quantum world. Cause and effect doesn't work the way we know it. This isn't just a technical physics problem. These are fundamental questions about the nature of reality. If the past can be changed, what is real? If the observer plays a role in measurement, is there objective reality? If multiple histories exist simultaneously, does this make sense? According to some interpretations, consciousness is an integral part of the measurement process. This means the universe is incomplete without observers. According to other interpretations, information is more fundamental than physical matter. Changing the past is actually reorganizing information. Some see the universe as a giant quantum computer. Changing the past is just recalibrating the computation. To be honest, nobody really knows what's going on. Even our best theories are incomplete. Quantum mechanics is incredibly successful, but we can't conceptually understand it. Copenhagen interpretation, many worlds theory, pilot wave theory, spontaneous collapse models, they all give different answers, but none are satisfying. Maybe future discoveries will solve these mysteries. Maybe new mathematics, new experiments, new concepts. Or maybe these questions are beyond what the human mind can grasp. Science isn't about reaching destinations, it's about the journey. Every answer opens new questions. Meanwhile, the quantum world is everywhere in our daily lives. Your computer, your phone, LED lights, all products of quantum physics. The technology you use daily is based on mysteries we don't understand. And that's actually a wonderful thing. So what do you think? Can the past really be changed? Or does it just stem from not understanding what measurement is? Share your thoughts in the comments. Even among scientists, there are big debates about these topics. And if this video made you think, there are more videos about other mysteries of quantum physics. Don't forget to subscribe, because science is the greatest adventure, trying to understand reality, and we still have so many questions to answer. See you tomorrow.